Hey guys, in today's video I'll be going over proof by contradiction, and a proof by contradiction is just one of the many methods that mathematicians use to prove mathematical statements. So, what is a proof by contradiction? So, let's say we want to prove a statement A. So our first step in the proof would be to assume not A or the negation of A, and this symbol over here is used to denote the negation. So, using our assumption, we want to find some sort of contradiction with our proof, something that's obviously wrong or false. And using that contradiction, we want to make the claim that not A is true and not A is just A because these two cancel out. And yeah, that's in essence what a proof by contradiction is. And next we'll be going over a example of a proof by contradiction, and it's probably one of the most well-known example of using this type of proof, and we will be proving the irrationality of square root of 2. So we want to prove that root 2 is irrational. So let's begin our proof by assuming the opposite. So assume root 2 is rational. So what this means is that root 2 is A divided by B is equal to that, because that's the definition of a rational number, where A and B are elements of integers, and obviously B cannot equal 0 because, it can't divide by 0. And let's make one other assumption, that the greatest common divisor of A and B is equal to 1. So what this means is that the fraction A over B is in its lowest form. So for example, 4 over 2 is not in its lowest form because 4 and 2 can both be divided by 2, and it's equal to 1 over 2, and this is in its lowest form. So that's what we're meaning by saying the greatest common divisor is 1. So if we square both sides, we're left with 2 is equal to A over B squared. And if we expand the brackets, we have A squared divided by B squared. Next, what we could do is multiply both sides by B squared, and we have 2B squared is equal to A squared. So, as you can see, the left-hand side is a multiple of 2, which means that it is even. And it's equal to A squared, which means that A squared is divisible by 2 because it's also a multiple of 2. So, one interesting thing that we could use is something called Euclid's lemma. So it basically says if a prime number divides AB, then the prime number divides A or it divides B. So in our case, 2, which is a prime number, divides A squared, which is just 2 divides A times A. So it divides A or A, and since they're both the same, this just means that 2 divides A, which means that A is divisible by 2. So using this, we can rewrite again 2b squared is equal to a squared. You should know that an even number is equal to 2 times k, where k is an integer. So we could replace that with a. So we have 2b squared is equal to 2k squared, and when we expand the brackets, we're left with 2b squared is equal to 4k squared. And next, just divide both sides by 2. We have b squared is equal to 2k squared. And now the right hand side is an even number, which means this side is also an even number. And using the similar logic of Euclid's lemma, we know that b is divisible by 2. And now you may notice that this leads to a contradiction, because we stated over here that the greatest common divisor of A and B is 1, but clearly A is divisible by 2 and B is divisible by 2, so the greatest common divisor of A and B cannot be 1, which means there's a contradiction, and hence root 2 is irrational. And that concludes our proof. We could denote it by a square at the corner. And yeah, thank you so much for watching, and if you found this video useful, please be sure to like and subscribe.